Hi, everyone, and thanks for joining us for today's webinar, where we'll discuss Java trends in the enterprise. My name is Alex Bradley, and I'm Senior Director of Corporate Communications at Azul, and I'll be your host today. Before we begin, I have a few housekeeping items. On your screen, you'll see a Q&A chat window. Please add any questions that come to mind, since we have reserved time at the end for our speakers to answer those questions. We're also recording today's session, and we'll send it to you following the webinar. Finally, we have a short survey at the end, so please fill this out so we can know how we're doing and how we can improve our webinars in the future. Now let's get started. We're joined today by two Java experts who will discuss the latest Java trends and important strategies for improving efficiency in today's economic climate. Today with us is Simon Ritter, Java champion and Azul's deputy CTO, and Eric Koslow, a security expert and senior director of product management at Azul. Welcome, Simon and Eric. Please introduce yourselves.
Hi there. Yes, welcome, Alex. My name's Simon, as you said, and I am the Deputy CTO at Azul. I have what could be described as long experience with Java. I started at Sun Microsystems way back in 1996, about the same week almost that JDK 1.0 came out, and I followed that all the way through the Sun years, and then 5 years at Oracle, and for the last 7 years, I've been doing pretty much the same thing, promoting Java at Azul.
My name is Eric. I've got about a decade of application security expertise specifically focused on Java. So whereas a lot of people focus on operation and performance, my expertise is breaking into systems and defending them. And I'm pretty good at knowing the threats that Java faces.
Great, thanks. Okay, let's dive into the first topic. Layoffs are increasing. The age of grow at all costs is dead for now. Cost cutting and efficiency are the name of the game. So against that backdrop, where do you see companies struggling the most to manage costs?
Yes. So what we're seeing at the moment is this thing that Andreessen Horowitz have called the cloud paradox, the $1 trillion cloud paradox. And it's the idea that people are saying to themselves, right, we have these applications that we run in our data center, and we want to move them to the cloud, because by moving them to somebody else's data center, we can take advantage of economies of scale, and we can reduce the cost of running those applications. We don't need all the people to manage our data center. We don't need to maintain the hardware and so on. Leave that to somebody else. So the overall impression is that if you just take your applications and you move them into the cloud, you will save money. And what a lot of people are seeing is that they take their applications and they move them into the cloud, and they actually end up paying more money for running the same application. And that's because there's this kind of fundamental misunderstanding, if you like, about what you need to do to move an application into the cloud. Lift and shift isn't necessarily going to give you the benefits that you expect. What you really need to be doing is thinking to yourself, how can I take advantage of the way that the cloud works and the way that I have that elasticity and the utility pricing model, really make that a benefit to me. And so what we see is a shift from the monolithic architecture that people have tended to use in their own data centers to this idea of microservices, break the application up into a number of discrete components and have those scale independently. And certainly if you look at some of the companies that have made a successful switch into the cloud, that's the kind of thing that they do. If you talk to people like Workday, they'll tell you that because of the way they've architected their applications and in the cloud, that they've seen a 95% reduction in operational issues over a period of like 18 months. Another example is like Supercell, where they've had a 20% reduction in CPU utilization by changing to a more structured, more microservice type of architecture. And that's enabled them to have higher carrying capacity in their services for the same instance size. And again, that reduces their costs. And again, I mean, another great example is MasterCard. You know, they moved into the cloud and they were seeing garbage collection pauses, literally 10,000 garbage collection pauses a day. And they managed, by altering the way that they deploy their applications, they reduced that 10,000 to 0. So I think that's really what we need to look at, is this alternative approach to how we use the cloud, rather than just treating it as a way of simply moving applications from data center to the cloud.
So every company is on some phase of that cloud adoption journey, whether they're sort of, rapidly adopting and still figuring things out, or on the other side of the spectrum, whether they're value optimized, like the companies that you just mentioned, or somewhere in the middle, right? Facing the cloud paradox, grappling with cloud cost optimization, et cetera. So my question for you is, for the people that are in the middle phase and grappling, do you think they're regretting embarking on this cloud adoption journey? Are they thinking about repatriating workloads to on-premise? Are they pot committed? Where are they at? And secondarily, how can they start to streamline those costs that they're experiencing?
Yeah, I think this is one of those things where it depends on the company, because as you say, we've seen companies who've gone, right, we're going to take our application, we're going to move them into the cloud. And then some applications, people have said, well, actually, it's because it's more expensive, we're going to repatriate them and bring them back into our data center. And they've done that because they haven't been able to adjust quickly enough in terms of re-architecting their applications to take advantage of those things. And I think that that's one of those things where it depends very much on the company that's involved as to what their strategy is around deployment of applications. And they need to consider carefully, does it make more sense to leave applications in their own data center? Can they take advantage of the benefits of the cloud? Because ultimately what they really need to do is move their applications into the cloud, unless there's some very specific reason for maintaining it themselves, because it's kind of like, electricity generation. You don't want to have a generator in your house. You don't want to have a generator in your office building. You want somebody to handle that for you. And it's much easier to have that utility-based pricing model. So we need the same thing for computing. And enterprise applications are very well suited to this idea of hosting them wherever you want to. So I think it depends a lot on the individual company, but ultimately, we should see people making that switch to the cloud.
Okay, so this is a Java Trends webinar. So what does Java have to do with all this? And I would even throw into that, the companies are increasingly turning to other open source technologies as well. So how does Java play a role here in reducing infrastructure costs?
Yeah, I mean, this is one of those things, isn't it? Because people, run a lot of applications on top of the Java runtime. And so when they move to the cloud, they want to get the best possible performance for those applications. And there are certainly things that you can do in terms of that. Now, the thing is that you've got a Java runtime. So there's a thing called the Java virtual machine that's a managed runtime environment for your application. Now, that's incredibly powerful. It's the reason that Java has been so successful over the nearly 3 decades that it's been around for. It allows scalability that you don't see with many other platforms. And it's why we've seen, people like Salesforce, people like Workday, eBay, and so on, these internet scale applications, because they can scale up to the workloads that they need in using Java. But that doesn't come without a cost. And there are certain aspects of running applications on Java that can sometimes interfere with what the application is doing. I use the example of MasterCard and the 10,000 garbage collection pauses every day. That's one of those things that hits people when they use Java, is that they often see garbage collection pauses, and that interferes with the latency, the ability to respond in a timely manner to requests from their customers. But there's other things as well, because of the way that the JVM works in terms of taking application code in a neutral format, what's called bytecodes, and then we compile it as the application is running. This is called just-in-time compilation. Again, it's a very powerful way of doing things because it does allow you to optimize the code based on what the code is actually doing rather than what you think it might do if you compile it beforehand. But that again comes with a cost, because you are doing that compilation whilst the application is running. So one thing is it takes away resources from your application as you do that compilation, but it also takes time to do the compilation at that warm-up phase. So one of the key things that you can do in terms of improving that and getting better efficiency for your applications and your microservices in a cloud environment is to find a provider who has a different approach to how the JVM works. So if you can solve the problem of garbage collection by using a different algorithm and use a pauseless garbage collector, which doesn't interfere with applications from a latency perspective, that's one thing. Second thing is, if you can find a better way of compiling the code that you get from your JIT compiler, then that will give you better overall performance, higher throughput, which is what you're going to need. And then the last thing is that idea of warm-up time. There are various technologies and techniques that can be used to improve that so that you kind of front load a lot of that and you can reuse information from previous runs by taking profiles and allowing those to be reused when the application or the service starts up again. And that's very much about giving the JVM in effect some sort of memory of what had happened before. So finding a provider of a Java environment that can do that for you, and I'll say it like Azul, then that's a great way of improving the efficiency of how your applications run without actually making any changes. That's the big thing. So, if you're running things like Cassandra, if you're running things like Kafka, you change the JVM underneath, don't have to change any code, don't have to recompile any code, but you can get potentially much better performance from that.
So let's transition off the cloud and let's talk, the Java ecosystem itself. There's been some big changes within the Java ecosystem. As most of the audience knows, in January, Oracle announced its 4th Java pricing change in 4 years, and the industry reaction has been swift. So Simon, what exactly has changed? What does this mean for our Oracle Java customers and the industry at large?
Yes, it is interesting to see this fairly regular change that Oracle make to the way that they price things. What hasn't changed is the licensing, and that's something that people do get a bit confused about. There's no changes in terms of the way that the Oracle JDK is licensed. So there's still what's called the Oracle Technology Network License Agreement. There's still the Oracle no-fee terms and conditions. But what they have done is they've said, if you need to buy a Java SE subscription, and the number of places where you need to have a Java SE subscription has increased greatly from when they used to use the older license, the Oracle binary code license, as it was called. So if you're running JDK 8, update 211 or later, if you're running JDK 11, and pretty soon, if you're running JDK 17, you'll be required to buy a Java SE subscription. In the past, the way that Oracle have determined how much the license would cost, the subscription would cost, it's been based on the number of cores that are used to run the Java applications. So what you do is you look at all the machines you have running Java, you count up how many processors there are, how many cores within that processor, add those all up, and then there was a slight wrinkle, which was the core multiplier. So depending on what type of processor you were using, you then had to have a multiplier that you would apply to that, and that would come up with a total number of cores that you needed to then provide a subscription for. So that meant that the less machines you had running Java, the less you would actually pay. What they've now said is to simplify things, is that all they're going to do is say, look at how many people you have in your company. So how many employees do you have, including temporary employees, including contractors, and including any companies who are basically doing IT services for you, and how many employees they have that are working on your account. Add all of those up, and then that is how they will price for your Java usage. If you've got 10,000 people working in your company and you're using one Java application, you are going to be paying for 10,000 people to use that one Java application, even if only half a dozen people actually use it. So it's a very different way of applying the licensing and the pricings to that.
It's really a staggering change. So what would you say are the top reasons an Oracle Java customer should think about migrating off of Oracle? And the second part of that question I'd say is, if they are thinking about migrating off, what should be in the consideration set for an alternative Java runtime?
Yeah, I mean, the really simple answer to that first part of that question is going to be cost, because if you're not already paying a large amount of money to use Java in your estate, then with a switch, as it will come eventually to you in terms of moving to this licensing based on the number of employees, there may be a few situations where you'll actually see a reduction. But what we've seen, certainly in terms of talking to many customers already, the chances are that the price that you'll be paying for your Java SE subscription is going to increase substantially. So that's really the reason that most people are going to look to move off of Oracle JDK. They're going to be thinking, right, how can I do the same thing for less money? And that's really the most important thing, is when you're looking at an alternative, is it going to provide you with exactly what you already get from the Oracle JDK? Now, most of the alternatives that you're going to be looking at are builds and distributions of OpenJDK. That's the open source project that was created back in 2006 by Sun Microsystems. It was open sourcing Java. What that allows people to do is download the code, build it, and then they can provide it as a distribution. It's the same idea as Linux. You have Ubuntu, you have Red Hat, you have SUSE, and many others. So the same thing applies with OpenJDK. You can have different distributions of the JDK. So what you're going to be looking at is, does it provide you with the same set of functionality? Does it provide you with the same facilities that you had before? Now, because it's based on the same source code, functionally, it's not really going to be any different. You should get identical runtime. What you'll be looking at as a customer is, what do I get around that? So will I get updates in a timely manner? Will I get support from the organization, the distribution? If I have a problem, I need to get that resolved. Is there somebody I can call? Is it going to be that I have support for older versions? So Java is 30 years old, and a lot of people have got JDK 6 running in their application, JDK 7, JDK 8, and so on. So can you still get support for those older versions that you need? And then there's one sort of more subtle thing, which is around how updates are delivered. Because if you look at the way Oracle do that, they provide two different versions of each update. And that's what's called the CPU, or critical patch update, and the PSU, which is the patch set update. Difference between them is that the CPU is all about security. It's the idea that it only contains the changes which are related to security patches addressing vulnerabilities that have been fixed in that update. The other one, the PSU, is the full update. So it's those security patches plus everything else, bug fixes, performance improvements, all those sorts of things. To give you an idea, the number of changes you're likely to see in a CPU is going to be, well, mostly less than 20, versus the number of changes you'll see in a typical PSU is going to be 200, 300, 400 changes. Now, the real relevance of that is that by having so many changes in the full update, there's a significantly higher chance that that will actually introduce a problem by fixing one thing, which then breaks something else. Good example of that was fairly recently. There was a change that was introduced to how the user directory within Java was actually changed. And so they limited how you could do that. And that actually broke Gradle, which is one of the build systems that's used by many enterprises to make their applications work and build their applications. So it's things like that. Now, if you have access to both the CPU and the PSU, because the CPU has not been affected by any of these regressions that we've seen, you can deploy that very quickly, do some testing, make sure that everything works still, deploy that into your estate, and have any of those CVEs addressed. So it gives you the maximum level of security. So having both the CPU and the PSU is very important to maintain that security and compliance if you're working in one of those industries that has compliance regulations. So these are the kind of things that you're going to be looking at. How can you get an identical service that you got with Oracle, but at a lower price?
I think that these pricing changes highlight a lot of the unpredictability and the risks involved of staying with Oracle Java. But there are other risks facing companies operating large Java estates. According to Gartner, attacks on the software supply chain are expected to triple over the next few years. So my question for Eric is a shift left supply chain security strategy enough to prevent the next Log4 shell?
I mean, shift left is a term that the security industry came up with a couple years ago. And what it does is it refers to the concept of taking a security control, like thinking about security flaws early and putting it into the development cycle. So I think shift left approaches where developers consider security in advance are good approaches. They help you with things that you're actively developing. And when you have a constant and frequent CI/CD process for a piece of code, shift left is a good set of activities to do. But it's not really enough to hit and keep Log4j out, because a lot of applications go into maintenance mode. Other times you get a library from a contractor. They shaded their own components into a library in order to avoid patch conflicts. So you can shift left all you want, but what we need is some context of what do we have that's providing us information back to the left where we do the development, which is production insight. Like if I want to improve performance, I should observe the performance of myself. If I want to improve security, I should observe my security flaws. Otherwise, what's happening is a lot of organizations are just building up giant backlogs of vulnerabilities, and they have Log4j everywhere. I think there was a large survey of some organizations a while ago, and each company had like 57,000 vulnerabilities or something. It's a really high number. And the problem is they can't prioritize all of those things to figure out where they are or which ones of them actually matter. Like Quarkus, everybody was false. A lot of security scanners that shifted left were false flagging Quarkus applications and saying, you're vulnerable to log4j. And they did it so much that the Quarkus project had to publish a blog saying, no, we're not vulnerable to log4j.
So a lot of companies in the security space seem to be saying, dev and security don't get along. Developers love us, so we'll help you. What's driving this common message?
Yeah, sometimes when you go to security conferences, like every company has kind of the same 3 words up there, and the trend right now seems to be, there's a lot of friction between security and development. Developers love our tool. We'll help you be trusted in, in the security environment by giving you context. Like those statements are all well and good. But it's just this role of we need security that provides context to developers so that people can actually fix things. Otherwise, what happens is a lot of people on the security teams whose job was to worry about things, they didn't really have the ability to impact it. So what they do is they build up this giant backlog of things to worry about. And the people in that space really need ways to get things off their plate, which is giving some level of context to the people who can do something about it. So the delineation is developers, the job is I build stuff. Security, the job is I worry about stuff. And how do you get people to decrease the amount of worry?
So that concludes our conversation for today, but I wanted to encourage everyone, keep submitting your questions. We left time at the end for questions. We've gotten a few already, but please keep submitting them. We'll try to get to as many as we can. First question, this one's for Simon. How well suited is GraalVM for Java applications in the cloud?
Yes. So GraalVM is an interesting piece of technology. It was developed, started developing in Sun Microsystems. It came out of Sun Labs. And it's an alternative approach to running actually multiple different languages. So it's a polyglot runtime, but Java is one of the things that you can run on top of that. And people have looked at GraalVM as an interesting approach to solving some of the issues that I talked about earlier on in terms of the way that the Java virtual machine works. This idea that it takes time to warm up and you have to wait until the code compiles as the application is running. So one of the things that you can do with GraalVM is create native images. Essentially, what you're doing is compiling the code before you deploy it onto your machine. So you compile it for the specific platform. And that way, when you start the application, there's none of this just-in-time compilation that goes on. So you don't need to take away the resources in terms of CPU and memory. And you get instantly the speed, the maximum speed of the application, which is great, so that obviously addresses some of the problems that people are seeing. And so what I always say when I talk to people about the way Graal fits into this picture is for certain things, this works really well. So if you've got very short-lived services, AWS Lambdas, the massively inappropriately described serverless computing, which, I don't know how you run something without a server, but serverless computing, very short-lived, ephemeral services, then this kind of thing can work very well because you don't need to wait for them to warm up. You can use them at full speed straight away. However, the moment you start going into longer running services, then you start to see that although you get fast startup, the problem with doing ahead of time compilation is, again, like I said earlier, the fact that you're not able to see what the application is actually doing as it runs, and so you can't optimize based on that information. So you're doing ahead of time compilation, you compile it guessing what's going to go on, but that won't give you as high a level of performance as you will with JIT compilation. Now, if you use the enterprise version of GraalVM, then they have what's called profile guided optimization, where you feed back information into the compiler and run it again. But even that will not give you the same level of performance. So GraalVM, great for short-lived services, but if you're running longer services, then having a JIT compiler, speculative optimizations and various things like that is going to give you better overall performance. So that's the way I kind of describe it, is that Graal is great for some things, but most of the time, certainly for longer running services, you're going to be using the JVM.
So if I could chime in, I was using it a while ago to build some little microservices for myself. I always think it's cool to try something new. It's always neat to do some stuff, but it took about 10 minutes for me to compile the application, during which time my laptop got so hot that I had to take it off my lap. It took so much memory that I had to figure out how to tune Docker to give it more memory. So if you change your Lambda on a regular basis, I feel like you're going to turn your usage costs into compilation costs. Neat approach, some good stuff. And I also learned when I went to run my application, it didn't work the first time because there's a reason that like Quarkus and Spring have their own native AWS integration libraries, because there's apparently a difference between the standard HTTP components library and the ones that they provide. And you had better know that before you compile and run.
Okay, we got another question here. Why should someone choose Azul Zulu instead of Oracle's own OpenJDK? And I don't think we mentioned Zulu on the call. So Simon, why don't you give a quick refresher on what it is and then why they should choose it over Oracle OpenJDK?
Yes. So, I talked in answer to one of Alex's questions about, what people would look for in terms of moving to a different JDK. And so I kind of went through the idea of OpenJDK, that's the open source, different distributions. So what we do at Azul is we create a distribution which is called Zulu. And the idea is that we do take exactly the same source code as a starting point. So OpenJDK, we download the scripts that we use to build that. So everything is identical from that point of view. Functionally then, what you get in terms of Zulu is identical to the Oracle JDK. So it is a drop-in replacement. You don't have to change any code, recompile anything. You can just redirect your application to pick up the Java runtime from wherever you install Zulu, and everything will work in exactly the same way. That's great. But there's more to it than that, you see, because the other things that I mentioned in terms of if you have, you need updates to this. So one of the things that we do is we provide all of the scheduled updates, all of the out of bounds updates, and we are part of the what's called OpenJDK vulnerability group, which means that we have visibility of the security patches as they're being developed. That means we don't have to wait until Oracle release the update before we can start doing the backporting of those changes to the older versions, which is what needs to be done. That means that when Oracle release their update, we can have our updates to Zulu available literally simultaneously. To date, we've done all of our updates available within 1 hour. I think the slowest we did was 59 minutes, fastest was 23 minutes. And that's very important from a point of view of being exposed to vulnerabilities, because if you have to wait weeks for the updates, then the moment the update comes out, all of those vulnerabilities are exposed in terms of the release notes, so people can start trying to create exploits to those vulnerabilities. By having the update available simultaneously, you can deploy that as quickly as you want. I also mentioned the idea of the CPU and the PSU. So with Zulu, we provide both of those. That means you can deploy a security-only update if you need to very, very quickly, get your systems as secure as possible, do more testing, make sure your applications work, then roll out the PSU if you need to. And so you get maximum security, maximum stability with that. Support, if you do have a problem, we have a very experienced set of engineers who can help you with that. So that's really what Zulu is all about. It's giving you this identical, if not better, service than you get with the Oracle JDK. So that's why people would choose to use that, and many people have.
The CPU and PSU stuff you just mentioned is actually a really good segue to this next question that just came in. So the question is, are there any features offered in Oracle versus Azul? I could read that kind of two different ways, so I'll sort of interpret how I'm reading it. Number one, is there anything that Oracle offers that we don't? Speak to that. Vice versa for Azul. What do we offer that Oracle doesn't, which is substantial actually, with a couple different product lines. But also, could you just transition explaining the CPU and PSU and how Oracle and Azul offer these compared to, let's call it, the other vendors, and just kind of clarify that and then take the rest of the question?
Yes. So if you look at other distributions, and I'll give you a couple of examples. So Adoptium from, or I should say Temurin from Adoptium, Corretto from AWS, they will provide you with updates to their JDK, but they don't provide both versions. They will only provide you with the PSU, so the full update. You don't get security only update. Now, just to make life a little bit more confusing for users, if you look at Amazon specifically, they will call it the CPU, even though it's actually the PSU. So They only provide one version. It is the full update. So in answer to the question about are there any features offered in Oracle versus Azul, from a sort of service level, no. We provide all of the same things that you would get from Oracle, right down to that like CPU versus PSU thing. Now, from a functionality point of view, there are a couple of things that you would need to look at if you're using older versions of Java, because going back to JDK 8 or JDK 7 or JDK 6, and that's one thing I must actually mention here in terms of benefits of using Zulu. If you have applications running on JDK 6 or JDK 7, we still support those. We're providing security updates and bug fix updates to that, backported from the current release out until 2027 at the moment, and we may go further than that. But if you look at those older versions, the Oracle JDK included some things that they classified as commercial features. They weren't really technically commercial in that you had to pay for them, but they called them commercial features. Things like Java Web Start and the applet browser plugin. JavaFX was another one that wasn't included in OpenJDK directly. From the point of view of Azul, we have a build of Zulu which includes JavaFX. So if you want to use that, that's not a problem. That was open sourced. Java Web Start, we have a version of ICE-T-Web, which was a project started by Red Hat, being an open source implementation of the Java Web Start technology. We can provide that to our customers if they need it, so they can still run Web Start applications. Applets, really are sort of dead. If you're still running applets, it'd be very surprising because even the Internet Explorer isn't supported by Oracle now. Isn't supported by Microsoft, and Oracle have even stopped supporting the browser plugin, so they aren't making any changes to that either. So there are a number of things we can do in terms of supporting those features.
Okay, and I'll add something briefly, and then I'll toss it over to Eric. Oracle also doesn't offer Platform Prime, and Platform Prime is the best JVM in the world. It's fast. It's great for lowering your cloud costs. It's great for performance-driven applications where all you need is speed, and it's paramount, which is increasingly most applications today. So Platform Prime is, of course, an immensely differentiated offering that Azul has versus Oracle. The other thing I'll kick over, though, is to Eric. Eric spearheaded the launch of a pretty innovative new product for the entire Java ecosystem. So Eric, why don't you explain what that was as well? Still answering that initial question of what do we offer that Oracle doesn't?
Yeah, sure. So we just launched something called Azul Vulnerability Detection, which helps organizations get an understanding of their security posture where they run Java, simply as a byproduct of running the application. So unlike a lot of situations where your security team keeps coming to you with scanners and telling you that you have this library, therefore you're bad and you need to fix it, what Azul Vulnerability Detection does is it just takes advantage of information that the JVM already has, like what are the libraries, takes its understanding of what code it loads, and then maps those against CVEs, which are vulnerabilities. So what you get is the same data that you're using to scanners to get today, but you get the benefit context of, do I actually load this code? So like when people come to you and they say, you have this vulnerability, therefore you're bad, you can look at it and say, you know what, that library is not actually used. So I'm going to focus on my more important things right now.
Well, good. On that happy note, we're over time. So thanks everyone for joining. Thanks Eric and Simon for speaking today, and we will share the recording after the call. Thanks everyone. Have a great day.
Okay, great. Thank you very much.